NSC, report spacecraft go.
Spacecraft is go.
Copy that, thank you.
Map is on internal power, ready for launch.
Copy that, thank you.
Adriana Ocampo is a space explorer. She's not an astronaut. She's a NASA geologist on a quest for space objects on Earth. Not now, but millions of years ago.
I love what I do because it's a dream that we all have to be able to just go and play in the dirt, and I'm able to do it for a living. And in the process, I also learn a lot about science, and that's what keeps it exciting because every moment can be a discovery. Oh my God, guys, we found it! There is enough evidence that has been presented that we can say that there was a big asteroid comet that impacted the Earth and caused a global mass extinction. You really have to be doing the detective work to identify impact craters.
NSC, report spacecraft go.
Spacecraft is go.
10, 9, 8, 7, Niners armed, green board, 5, 4, 3, 2, 1, and liftoff of the Delta II rocket exploring the past and future of our universe. Vehicle on course.
A planetary geologist has the opportunity of learning more about our planet by studying the planets in our solar system. And it's a relatively young discipline that really got started with space exploration. We look at images that have been radioed down from the spacecraft that are orbiting Mars, for example, and then we study them in detail and manipulate them with computers and develop different techniques that will allow us to learn from them and then compare it to our own planet, the Earth.
Adriana combs through hundreds of remote sensing photos each year, but one image stands out. It's an ancient impact area in remote South America, and it's become the focus of her field work. Today, she's reviewing the images with geologist Kevin Pope.
Here we have the ground zero then in the Yucatan Peninsula, Chicxulub impact. We're in the process of planning our expedition to Belize and the Yucatan Peninsula to study the material that created the Chicxulub impact crater 65 million years ago. The Chicxulub story started with a Landsat image taken by a spacecraft. There was a very intriguing feature. There was like black dots that were, as you put them together, form a semicircle. These black dots turned out to be pools of water, what they're called sinkholes, or in the Mayan Spanish word would be cenote. And it was very intriguing because this was an enormous feature that you could only see it from a point of view of a spacecraft. It was over 110 kilometers in diameter. It was the surface expression of a buried impact crater.
But to make sure that what they are seeing in the photographs really has occurred in the ancient past, they need to go to the source.
Belize is a wonderful locality. It's very beautiful. There's a lot of lush vegetation and beautiful wildlife. But it's not your typical place for geologists. Geologists tend to go to deserts, places where you have rocks readily accessible and there is not very much vegetation. This process of finding and searching was quite challenging. We're in Hummingbird Highway between Belmopan and Armenia. These localities in Belize are really unique in the world because they are the only ones that show what happens after the first few seconds and minutes and hours after the impact. What we had to do is look for quarries, areas that already Man have come and digged up the rock and was pouring it, in this case, to build the roads in Belize. Okay, guys, welcome to Albion Quarry. Here we are.
Albion Quarry is enormous. A gaping hole in the ground made from mining boulders to make gravel for roadways. And for all the time that quarry workers have been hard at work making gravel, they've actually created a huge science lab blasted out of the rock. As they make their way to examine the rock layers up close, Adriana's excavators are literally treading on the Chicxulub catastrophe. The ground beneath them is rocks and boulders ejected from the asteroid impact 65 million years ago.
And it's unique in the world because it's the only place where we can come and study the material that was ejected from a large impact event. In the other impacts craters around the world that still exist, all this material has been eroded, so we don't have an opportunity to come and study it.
Working in the quarry, Adriana has found a passion for space exploration here on Earth. With each rock sample, she is unearthing clues about heavenly bodies that have impacted our planet in the far, far past.
Since I was a very little girl, I was dreaming about space. It just completely intrigued me. I used to just climb to the roof of my house in Argentina back there and trying to view the stars and wonder what were those sparkle of lights.
Apollo 11, this is Houston. All your systems are looking good going around the
I
corner.
very much recall very clearly on July 20th of 1969 when I was in Argentina watching through TV the first time a human being stepped its foot in another planet.
That's one small step for man, one giant leap for mankind.
And I realized, gosh, that's fantastic. I couldn't believe we were viewing images from another world. And these incredible soils and rocks, and that completely intrigued me, and I realized I was hooked. And that's how planetary geology came into my life.
Working in the quarry is like stepping back into time.
Let's go back 65 million years ago. There were dinosaurs all over the place. Beautiful lush vegetation, nice coral reefs and leo crabs and fishes all through this area. And then all of a sudden, out of nowhere, a rock came from the sky, probably an asteroid or a comet, impacted on the Yucatan Peninsula. It produced tremendous earthquakes, over 10 in the Richter scale. There was global wildfires that spread to the planet. We had incredible masses of dust and clouds of very poisonous gases that just completely enveloped the whole planet. Our whole atmosphere was completely covered with these very thick clouds of sulfur, of sulfuric acid. So we have sulfuric acid rain, and this effect lasted for about 10 years. That's a long time. It became a very unfriendly place.
So unfriendly that the dinosaurs and many other species died off. A global extinction had taken place. The challenge for Adriana and her team is to find proof that this catastrophe took place here. Today, there is no sign of a crater or the asteroid itself. It's like a crime scene without a body or a weapon. The ground beneath them is not the asteroid, nor is it the crater. It's rocks that were ejected from the ancient impact. The crater is 150 miles away and 1,000 feet below the Earth. But here, all that's left are signs of the tragedy within the rock layers. The most obvious clue is a ribbon of golden sediment that dissects the quarry. It is a dividing line in time, the age of the dinosaurs below and the age of the mammals above. The scientific name for the golden band is the KT boundary. The area below the boundary is a hard rock layer that the miners use to build roads. And hidden within this tough rock is the story of life before the asteroid impact. And inside some rocks are fossils. Not dinosaurs, but small creatures that lived during the time of the dinosaurs.
All of the members of this family have been found in lagunar environments, very shallow water.
So it's a crab?
Perfect. It's a crab. Here is the left claw and the right claw in the pinchers.
Poor thing was one of the last victims of the impact.
Right,
It really went extinct with the impact.
Right.
So we can really feel now comfortable saying that this is 65 million years that we're working in the...
We are very close to the KT.
Okay, so what is the next number?
Throughout the world, the golden band of the KT boundary lines the Earth, but nowhere else on the planet is the layer so deep.
What we're looking here is a beautiful example of the first few seconds after the impact. This is the material that just came at extraordinary velocities and just was deposited here in Belize. In other parts of the world, it's just a few centimeters, and here we have several meters of this material.
Within it, Adriana's researchers are examining special types of rocks, tiny rounded pellets that show evidence of a huge explosion and intense heat. Traveling at lightning speed, the rocks superheated and melted, forming beads of glass. Now, Adriana's researchers are setting up grids to record the measurement of every sizable rock, from pebbles to enormous boulders. The left side of this hill is actually one huge boulder.
It's humongous. It's the size of a house. The amount of energy that it must have imparted is like over 100 million megatons of TNT all going at once. You know, to have been able to move such tremendous masses over 230 kilometers away. So this boulder is composed of the same rock as the asteroid comet impacted, so it's part of the target rock.
Adriana needs more than one source of evidence to prove her theory that the Chicxulub impact took place. She wants to know how widespread the devastation was. To do that, she needs to prove the evidence at Albion Quarry isn't a fluke, a chance happening.
We cannot just find one single locality. It's very rare that will provide us with all the answers. We needed to find how extensive this was. Can we see those same rocks someplace else?
And for that, Adriana needs plenty of help.
Having the volunteers from the Planetary Society has been an incredible help.
I was a police detective for 27 years, and I retired last year. And I promised myself once I retired I'd go on an expedition, because I'm really interested in geology.
I'm a truck driver. I own my own trucking business. And I've always had an interest in science.
Scientist really is a good observer. And I think we are all scientists in all different ways. Being a keen observer, being able to note maybe subtle differences, and that's what all of these people share. They really are very good observers, and the volunteers have been tremendous in that way.
And I'm really, really loving this. It's as fun as any major undercover work I did in police work. It's putting all the clues together, gathering evidence carefully, taking notes, and then making a decision on what happened. Only in this case, nobody goes to jail.
New clues are emerging from a newly discovered rock sample called Pook's Pebbles.
So these limestones were traveling, re-entering, heating up. These very unique textures and features like the shine in the rock, like indentations. They got plasticized and they got basically imprinted for posterities, for future geologists to find.
Adriana has been trying to pinpoint how close she can find evidence to the original source of the impact. So the team heads to the Yucatan Peninsula of Mexico. Here, the group is searching the area closest to ground zero.
In Mexico, we have these pieces, these type of rocks, but spread all in different areas. So the challenge is locating them and then putting them together. And so here, right here, this surface represents that period of time. So we are pre-impact, post-impact. This little line here is that contact point. Actually, this locality that we just discovered now has become the closest locality to the impact in the world.
But just collecting samples of rocks in the field won't tell the whole story.
It's indicative of a rock that has been exposed to very high temperatures. And we believe that they were thrown from the Chicxulub impact crater all the way from the Yucatan Peninsula in Mexico to Belize, over 500, 600 kilometers away.
Scientific investigations require looking within the rocks for more specific clues, clues that can't be seen with the naked eye. One piece of evidence is called shocked quartz, the size of a grain of sand. The tiny streaks running through this grain show the pressure of the impact that literally shocked the quartz.
There is enough evidence on the table that has been presented that we can say that indeed the extinction of the dinosaurs was caused by a massive impact in our planet and bringing about global destruction.
NASA and the MAP spacecraft are ready for launch.
Why do we explore? The reasons that people climb mountains, the reason that people explore the oceans, the reasons that we send spacecraft to the farthest reaches of our universe is to enhance an understanding. Planetary geologists have a tremendous challenge because we cannot go to Mars or we cannot go to the moon very easily. So we have to make comparisons. Where can we go to the Earth to try to study those similar processes? As planetary geologists, we always have to, in a sense, be thinking about the stars or keeping our feet on the ground.